Welcome to a journey across the boundaries of the known universe, where scientific theory meets endless imagination. Today, we're diving headfirst into one of the wildest and most puzzling concepts of theoretical physics: white holes. They might sound like science fiction, but they're actually grounded in the same math that explains black holes. What if white holes are out there? What would they do to our universe? Could they hold the key to unraveling the deepest cosmic secrets? Get ready to explore an idea that could change everything we know about space, time, and existence itself. Let's start with the basics. What exactly are white holes? Imagine their infamous counterparts, black holes, cosmic giants that trap everything, even light, in their immense gravitational grip. White holes are their mirror image, at least in theory. Instead of pulling matter in, white holes expel it. They're like cosmic fountains, flinging energy and particles outward into space. But don't be fooled. They're not just figments of imagination. White holes appear as valid solutions in Einstein's equations of general relativity, the very equations that predicted black holes long before we ever observed them. Yet, unlike black holes, we have no direct evidence of white holes. They remain one of science's greatest what-ifs, suspended between theory and mystery. Picture this. In mathematical terms, a white hole is a time-reversed black hole. That means if we rewound the formation and behavior of a black hole like a movie, we'd get something very close to what science describes as a white hole. Fascinating, isn't it? Now let's compare these cosmic siblings. Black holes and white holes might sound like opposites, but how different are they really? A black hole devours everything unfortunate enough to cross its event horizon. Imagine falling into quicksand in space, but there's no way back. Even light, the fastest thing in the universe, can't escape once it's trapped by a black hole's gravity. White holes, on the other hand, operate in the exact opposite way. If you approach their event horizon, there'd be no falling in, because white holes don't let anything enter. Instead, they continuously expel matter and energy, almost like a cosmic fire hydrant. Imagine watching an explosion in reverse. A white hole might look like a constant big bang of material erupting into the universe. Here's the catch. While black holes form naturally, when massive stars collapse under their own gravity, we don't yet know how white holes would form. They require energy states and conditions that seem almost impossible, at least based on what we currently understand about the laws of the universe. But that hasn't stopped scientists from dreaming up incredible ideas about what role these bizarre phenomena might play. Now for the fun part. What would happen if white holes were real? Imagine you're an interstellar traveler cruising through space, and suddenly you encounter a white hole. What would you see? Some theories suggest you'd witness a dazzling, chaotic spectacle, streams of light, matter, and energy blasting out in every direction. But it wouldn't just look spectacular. White holes might hold the key to some of the deepest mysteries of the cosmos. One possibility, they could be portals to other regions of the universe or even other dimensions. Think about black holes. They're known for their mysterious connection to space-time, and some theories propose that they might lead to wormholes, theoretical shortcuts that could connect distant parts of the universe. White holes, then, might be the other side of that cosmic tunnel. Could a spacecraft enter a black hole, survive its insane gravity, and emerge from a white hole on the other side of the universe? It's the ultimate sci-fi concept, but there's a sliver of theoretical science supporting it. And the ideas don't stop there. Some researchers even postulate that our own universe could have been born from a white hole, a process similar to the Big Bang. In this view, white holes might not just exist as rare phenomena. They could be fundamental to how the cosmos itself regenerates and evolves. Entire worlds, galaxies, or universes could emerge from these cosmic fountains, pushing the boundaries of what we understand about creation and destruction. Of course, just to ground our imaginations for a moment, most of these ideas are purely speculative. We're venturing into the unknown here, somewhere between established physics and philosophical wonder. So if white holes sound so incredible, why haven't we found any yet? Well, the short answer is they're elusive, if they exist at all. Let's go back to Einstein's equations. White holes arise naturally in the math as a counterpart to black holes, but nature doesn't always follow every mathematical solution. Still, some famous names in physics have proposed intriguing theories about their existence. Russian physicist Igor Novikov, for instance, suggested in the 1960s that white holes could exist within the framework of relativity as one-way portals for matter. Even more recently, some scientists have considered whether certain cosmic events, like gamma-ray bursts or unexplained emissions of energy, might be tiny glimpses of white holes in action. There's even been speculation that very old primordial black holes, those that existed soon after the Big Bang, might eventually flip into white holes as they age. However, there's no direct evidence, no telescope image or experiment that confirms these ideas. For now, white holes remain in the realm of possibility. Tantalizing, yes, but unproven. In the end, white holes are one of the most intriguing thought experiments in modern physics. They challenge us to think differently about the universe, its origins, and its ultimate fate. While we still don't have concrete evidence that they exist, studying white holes pushes the boundaries of what we know and dares us to imagine a reality that's far stranger and more beautiful than we could ever anticipate. So what do you think? Are white holes waiting to be discovered? Could they lead us to new worlds or even introduce us to new laws of nature? Let us know your thoughts in the comments below. If you enjoyed this brain-bending journey through the cosmos, don't forget to subscribe to our channel. Hit the notification bell so you won't miss any of our future videos on space, science, and the mysteries of the universe. Thanks for watching, and we'll see you in the next video. Stay curious.